Hey, hi, good afternoon, everybody. And thanks a lot for taking out time to attend this event. It's a great opportunity to do this Kubernetes meetup, which we keep doing here at Cloudera. We try to do it almost every month. So this is our page, Future of Data Bangalore meetup page, in which we announce all the upcoming events. You can refer this and follow this to get to know about upcoming events as well. And this time, thanks to Prakash and Humble, we are collaborating with them. And it's always a great experience to do with them these meetup sessions. So handing over to Prakash now.
Hello, good afternoon. So welcome to the Kubernetes Bangalore September 2024 meetup. So good to see you all. How many of you are attending this meetup for the first time? Wow, quite a few newcomers, huh? So I welcome you all. So a little bit of history. We've been doing this meetup since 2016. So it's been about 8 years now that we've been doing this, about 80 plus events. And it's so good to see you all come here again on a Saturday just to share knowledge, learn from each other. Right. So you're encouraged to, if you click pictures or anything, just tag us on KTS BLR. We are on Twitter, we are on the meetup group. And in any case, you need to get in touch with any one of us. You can, all our contact details are also on the meetup group, right? But that being said, I won't delay us any further. We are already a little bit late. So first up, we have Divya. She works at GitLab, and she's going to talk about Kubernetes informers.
Hey everyone, this is Divya, and today in this talk, we'll be talking about informers, what they are, and how we can use it on a cluster. A little bit introduction about me. Currently, I'm working at GitLab in this team called Gitly, which is like a RPC service for all the Git operations that happen in GitLab. I'm interested in distributed systems and low-level programming, and have been working with Kubernetes and Golang for like past around 4 years. Now, a little bit about the agenda. Today, we'll be discussing about what are informers, shared informers. So informers could be of many types, and specifically, we'll be discussing about shared informers in this talk. What are the components? Now the work queue. So work queue is a data structure which can be used alongside with informer. And we will be looking at the types, and then we'll be looking at the demo, basically how we can use informers using the client Go package. So what are informers? So it's a client-side library that can continuously watch for Kubernetes resources. Now the thing is, like, a use case that we can think of is like why we need to watch continuously a particular resource. So we must be knowing something about controllers in Kubernetes. And so if somebody doesn't know about controller, it's an application which makes sure that the current state of your cluster reaches to the desired state, which is the current state of the client, which is to the desired state of the API server. Now, in this case, let's suppose, for example, we need to increase the replica of a pod and scale it to, let's say, 2. In that case, we need some kind of entity which would make sure that that actually happens. In this case, what would happen is controller will put a watch over all the pods and make sure that the replication happens. Now, in this case, just imagine like if we put a watch, then we must be wondering like, okay, what is the difference between informer and watch? Looks like both are the same thing, right? So before discussing the difference, we will look at like, what is the similarity here? In this case, both informer and watch use something called resource version. So if you have ever run a command like kubectl get pod, the name of the pod dash oyaml, you will see the resource version. Now, this acts like a key for all the informers and watch to keep track of the object. Now, why the source version? Why not a specific key like, let's say, namespace slash the pod name? That would work as unique key, right? So why not that? Now, in this case, why the source version is used? Because Kubernetes uses something called optimistic concurrency control. In this case, what happens is like all the requests will go to the API server, and the API server will match the resource version. So if it's old one, the request will get discarded. In pessimistic concurrency control, that wouldn't happen because the request will not be able to go to the API server. In here, we allow all the requests, but that will get discarded at the API server level. Now moving on. So now coming to the differences, Informers also uses watch stream, and the raw watch also uses it opens a long-lived HTTP connection called a keep alive connection. So both of them use the same thing, and but Informer use something called cache. Now, why do we need cache? In this case, let's take the example of controller. Now, if we need to keep track of object, let's remove informers and watch from the equation. What we would need to do is like request the API server again and again to get the track, to get the status of the objects. Now, that would put too much load on the API server as well as the HCD database, right? So that we don't want. So it would always be better to have a cache around, and the request will route to the cache rather than the API server. So Informer provides that. Now, in this case, any potential for missed events if watch is used. Now, how the event can be used? So we can think of a scenario like, let's say we have a job, a Kubernetes job. We deployed it, and we have a controller actually, which is supposed to watch for a job. But let's think that is actually using a watch only. It doesn't have any kind of cache or memory, nothing else. So in that case, let's say the job came in, it did something, and after 2 minutes, it got deleted. While this was happening, let's say a network partition happened, and the event got lost while you're watching that job. The thing is, in that case, that event, since it got lost, we will not able to act upon it because we don't know the history, right? Because we are not keeping any memory. So that would be a problem. So in this case, since Informer has the cache and the memory, we can actually relist what has happened before and keep track of it. So in like an example from a day-to-day job would be like, watch would be like a live news feed. So suppose we are listening to a news on a radio, and let's say I went somewhere, I didn't listen, then I lost the news, right? Nowhere, no matter what, I cannot recover it now. But Informer is like a full-blown smart news app. It's like you listen the news, you went away, now you can go ahead and search the archives, you can categorize it, and you can look it up, right? So that's the difference between a Informer and watch. Now coming to this, both Informer and watch, they use a long-lived HTTP connection, and like I said, a keep alive connection. But there are other ways to do polling, right? Now, in this case, Kubernetes, with the informers, they actually use both watch, long-lived HTTP connection, and polling as well. But there's a difference. Now, if we open a lot of, if we keep polling something, we need to open a connection on the API server. And if we keep doing it that again, it will put strain on the server itself. So it's always better to open a long-lived connection. Other than that, coming to the scalability part, now if I open a 10 long-lived connection and 10, let's say, short polling connection, both will put strain on the server. But in this case, long-lived connection, we don't need that many because one open connection can be used by many instances, right? So that would be helpful. Coming to the edge triggered and level triggered. So informers are actually both edge triggered and level triggered. So what is that? Now this is a concept from digital electronics actually. Edge triggered, let's say we put a watch on something and we get an event. Based on an event, we did something. Level triggered would be like, okay, we missed the event, let's say, but we continuously are trying to match the current state and the desired state. So what we will do is we'll go ahead and delist that event to make sure whatever we have missed, we can continue applying it and reach the desired state. So that would be level triggered. To know more about the level triggered and edge triggered, there's this article by James, and I will recommend everybody to read it. It's very nice, actually. Yeah. So shared informers. Now, Informer has something called shared cache. Uh, Given like there could be many controllers, right? Suppose like if we have 10 controllers and each of them open like a separate watch interface on that API server, again, that would be costly, what we're trying to avoid. So in this case, shared informer is something like it would have a shared cache and it would open only one watch interface on the API server, and that can be used across multiple controllers. So this would actually help in synchronizing, as in let's say some of the events, like let's say there are 5 different controllers and the events, they are not actually synchronizing, but given it's a one cache and everybody is just setting the same cache, that wouldn't happen. And also it's easily scalable. Now, components of shared informers. So there are actually 4 components. Actually, there are many, but these are the 4 major components. There's reflector. So reflector is the only one which will be talking to the API server. It will open the list watch interface. And once the reflector starts, it will try to delist all the objects from the API server at once and try to fill up the cache. There's delta FIFO. So from reflector, every event, whatever is happening, will go to the delta FIFO, and it will help in maintaining the order of the events and make sure that the deduplication happens. So what I mean by deduplication is, let's say I added a pod, and at the same time, just after a second, let's say I modified it. Now both add and update will get combined to one single operation. That's what delta FIFO would do. After delta FIFO, there's indexer. So we must be knowing about something called DB indexes, right? This is actually something similar. So you can think of it like different hash maps, and you can provide your own key on which you can do the faster lookup. That's where indexer will be used. Then there's shared processor. So shared processor will be actually putting a watch on indexer. And in case, let's say, any change that happens in indexer, shared processor will take it and will inform all the registered event handler to process it further. So this is where it comes all together. Here we have HCD, and this is the API server. Reflector is actually open a list watch interface here, and all the events will be put to the delta FIFO queue. There's something called handle data function, which will go inside the queue, and based on all the events, it will insert into the indexer. Since shared processor is already watching, it will get all the events and put in the listener, and then resource event handle will handle it further. Now, coming to the work queue, we must be wondering, okay, like what exactly work queue is doing there. So now, just a second. Before this, the resource event handler, it has all the events. Now it has to put somewhere, right? So that the consumer can consume, which is the workers. In this case, again, it's a simple data structure that holds the queue, and the format would be something like namespace/name of the object. And what it helps in, so if we have, let's say, a lot of traffic in our cluster, there would be a lot of events there, right? And then we don't want our workers, depending how many workers we have, to be overburdened. In this case, the queue would help to kind of rate limit. We can decide how many objects can be consumed at once. Again, it will handle the duplication and the retries. So what I mean by retries is like, suppose let's say controller is running and it was supposed to update something, but basically it got the element from the queue and it was not able to perform the operation. It can again insert into the queue right back. So that is the job of the work queue here. And here's the basically overall diagram. Actually, a better diagram is available on the Kubernetes website, but this is like a simple one. So in this case, yeah, resource event handler will put into the queue, and the workers will actually get the object, and then we can basically insert our business logic based on whatever you want to do with it. Now, types of work queue. Now, there are different types of work queue. Here I'm discussing only 2 because these 2 are the major ones. The delayed queue and the rate limiting queue. So delayed queue is like, for example, let's say I got an object and I don't want to insert it immediately. Again, maybe due to the load or maybe through benchmarking, I got to know some parameter which I should use. So in that case, I use the delayed queue. Now rate limiting queue, it actually extends the delayed queue, kind of a better version of it. So there are 2 types of, again, there are many rate limiters, but here I'm discussing only 2. It's default rate limiter and bucket rate limiter. So in default rate limiter, it's like if I care whether my operation got succeeded or not, then I'll use the default one. It will put the objects in the exponential backoff, and it will keep retrying. But if I don't care whether my object got processed or not, then I'll use the bucket rate limiter. In this case, if you want to make sure that the number of operations per second doesn't exceed a number of tokens, I'll use the bucket one. And I'll go to the demo to see how we can use it. Just a second, let me see. Is it visible? Let me share my screen again, just a second. Yeah, I'm just sharing my screen again. I'll just close this. I'll just do the desktop share. Okay, so before that, I'll just go over some code. Uh, so we recently saw indexer, right? We were discussing how it's act like a hash map. So we can see here we are creating a new indexer and we are defining the format of the key. Like I said, in this case, the format would be something like namespace and name. And again, we can modify it depending on whatever we want. Here we are defining the indexer. Is it visible now? Okay. Yeah. So in this case, what do we actually index on? So here we can see there's namespace and node name. So this is what we will use while we are searching some components there. Now with indexer, there are different components like add, update, and delete. Based on whatever we get from the Delta FIFO, whatever event that happened, we can use the indexer likewise. Like we can add some events, update or delete. And since there would be a shared processor watching that indexer and these events, it will update itself accordingly. And in this case, we actually added some pods here. And then we are trying to do a lookup. So in this case, we added the indexer name as namespace and node name. And we are trying to see like how many, let's say, pods are in the default namespace, or basically in this case, how many pods are scheduled on the node 1 node actually. Sorry, yeah, node 1 node. So we try running it. Yeah. So let me see if I can go to the indexer. And we can try running, I think it's, yeah. So in this case, pods in the default namespace will be 2, and the pods on node 1 is actually 2. So we can cross-verify this. So in this case, yeah, node 1, there are 2 pods here. And on the default namespace as well, there are 2 pods, right? So this works like a kind of a hash map, but not exactly. And then we'll move on to the demo of informers and how exactly it is used. Okay, I will go to the main function first. So this is the basic, extracting the config map. By the way, I'm using kind cluster here, and using that config to create a Kubernetes client set. After that, we'll be using the informer library to create a new shared informer. Now, in this case, I'm passing the client and also the time duration. So this is the time duration that will pass, like basically after how much time we are doing that periodic resync. I have put it 24 hours, but again, this depends on the use case that we want. And then we are creating a pod informer here. Now, given in this case, like I said, the shared informer, how it works, similar to pod informer, using the same factory, I can create, let's say, a deployment informer or a volume informer, something of that sort. And then I can actually create multiple controllers here and just pass the informer using the same factory. This is how they would have the shared cache. After this, we will actually run this factory. Why? Because we want to warm up the cache. So it will go to the API server, grab basically whatever objects that we want to put our informer on, and we'll fill up the cache. And then we can run our controller. So after the controller is starting, we can actually determine how many workers we want. Workers will be the one which will be actually consuming the work queue. So it could be 3, it could be 4, again, depends. And after this, we will add some jitter. Jitter because, again, we don't want to overload the queue that we're consuming. So if we put in, like, let's say at once 10 workers, right, they will all be accessing the queues at the same time, and that would be a problem. This we can determine the value based on some benchmarking, but here we have added jitter of 1 second. And then we'll see what workers are doing. So in this case, workers are running something called process next item. We'll go toward this and we see that this method called q.get. So it's actually grabbing the object. After we actually put a value out of the queue, we need to mark it as done. Before that, we need to mark it as forget so that it doesn't get requeued into the queue. Then here we actually seeing something called add rate limited. So before adding an object, obviously it's a rate limited queue. So we cannot just go ahead and add it. We need to make sure that the rate limiter is okay with it. So this is the function which will make sure that, okay, it's fine to add this one. Here before that, we are seeing something called sync handler. Now, once we have got the object, we can do whatever we want with it. In this case, I'm kind of just printing it out using that indexer. But again, once we got the key, we can get the namespace, get the object, and add our business logic here. In this case, we are just printing out the node name and everything. And now we will try to see and run it. Sorry. Yeah. So we can actually try to run the controller first. So in this case, it's actually processing the pods which are already existing on the kind cluster, which is in the uh, basically kube system namespace. So this is how it's actually processing, but we kind of will just deploy some pods and see how it's actually acting. So now we see like there are various events happening. So we'll start from here. Yeah. So first, the pod got scheduled. It's in the pending state, so it's printing that out. Now you will see with each event, whatever the modification is happening with the pod, we are seeing the event accordingly. So you see, like here, first it got in queued. After it got processed, then it was removed from the queue. But then something else happened. It got assigned a node here. Then it got in queued again. Once we process it, got dequeued. Then we are seeing like just a second, yeah. Then we seeing like it was assigned an IP and the status was running. So then we process it fully and then it was removed from the queue. Now since there are no modification happening to the pod now, so that's why there are no events coming up. So whatever events, let's say even if you change the image or something else, that can be monitored and that's how it will be put in the queue every time. Let's see if I try to, let's see if I try to delete this one. Yeah. So in this case, with the delete request, we see one event happened. Basically, this pod got in queued, and that got succeeded. And after that, it is successfully removed. We see the logs of that as well. So this is how actually this is like a demo controller. And again, there's a lot of things happening under the hood, how the indexes are being used, but the overall, this is how it works. Now we'll move on to the slide. Sorry, think. Yeah. So now what happens under the hood when we are running that shared informer factory, when we use that method, when we run that start method? So this is the whole function call stack, which is happening underneath. So after the run method is invoked, we have two separate Go routines. One is shared processor and one is the reflector. Remember, reflector is the one which is actually talking to the API server. And the shared processor is the one which is taking care of the index. So I was short in space. So I kind of added everything here. So in this case, I think we are missing the indexer, but I'll tell exactly where it will lie. In this case, when the runs happen, there's a process loop. Now the work queue also needs to be drained after a certain time. So that is what process loop will handle. Apart from that, it will trigger the handle delta function. So what is handle delta? Again, there's the delta FIFO queue. And from delta FIFO queue, we need to grab the elements and put it to the indexer. So this is what will be handled by handle delta and process delta. After things are inside the indexer, the process listener will be actually listening to the events and will put all the events in the resource event handler. And from there, it will get inserted to the work queue. And then it's open for consuming. And then depending on the number of workers, we can extract the elements and use it accordingly. I think, yeah, that's all I had. Thank you.
Questions? Yeah, we have 5 minutes for questions. Would you have any questions?
Does anybody has any questions? Oh, sorry. Yeah.
Hi, this is Sunil. I'm very new to this Kubernetes thing. So recently we started working with Kubernetes operators. So I just want to understand two things. One is, what is the business use case for this, where we can use this? And can we use this with the Kubernetes operator as well? Do you think there is a case, or how is it?
Kubernetes and controller and operator. So actually, both of them are, I'll say, not exactly same, but kind of same. How? So controller is used for something native Kubernetes, as in like the pods, deployments, and all those things. These are native. But if we decide to use something like a custom resource, that's where operator comes in. So in this case, again, the under the
All right. Hey, everyone. Good afternoon. Good to see you all on a Saturday afternoon. All right. So please bear with me. This is the first time I'm giving a talk at a meetup. Okay. So today's topic is extending Tecton's functionality via custom task and controllers. So before I start towards the talk, I'll give a short description or introduction about me. So I'm a senior software engineer at Red Hat. This September, I just completed 5 years. So past 3 to 4 years, I have been working on Tecton, and I've been maintainer of a few components in Tecton. It's an upstream project. So apart from technical stuff, I do like to play cricket. So yeah. So moving on to the topic, before I go ahead, just wanted to know, like, how many of you all are aware about Tecton or have used Tecton? Oh, okay, nice, thanks. So in today's agenda, I'll be just giving a brief overview of what Tecton is and how Tecton helps, and what are the challenges in a Tecton task, and how we use custom tasks, custom runs, and custom controllers to solve that, and just a small demo of like how custom tasks are used in a pipeline. So when you say Tecton, so Tecton is nothing but a open source Kubernetes native framework, which is used to create CI/CD systems. So it is used to build, test, and deploy the applications, and it simplifies the application management, I would say. And because it abstracts the Kubernetes resources, and it's the basic implementations of Kubernetes. So coming to the features, so the first feature is like what Tecton provides. It's like it can be built on any Kubernetes platform. So for example, OpenShift, VMware, Tanzu, IBM Cloud, etc. The next is scale on demand. Since every controller, it's the controllers running in a pod, so that's why it helps in scaling on demand as well. Next is secure pipeline execution. So when I say that every pipeline is different from other different pipeline, and also we have a feature called as supply chain security in Tecton, which is called as Tecton chains. I'll not go deep into that. That's all in all a different topic. And finally, it's flexible and powerful. So when I say this flexible and powerful, it means like it can be integrated with any Kubernetes providers. It can be used as with different SME providers. And when you define your task, under the hood, you write the scripts, what all operations you need to perform in a pod or a task run. So that's why it's flexible and powerful. Coming to the next slide, we have the building blocks of Tecton. So the first I'll go with what is step. So step is nothing but it runs a command or a script which you define inside a container. You can provide the environment variables using secrets, config maps, etc. Next is task. So task is the basic unit of a pipeline, I would say. It is nothing but a list of steps which are sequentially defined in a task. And the best feature of Tecton, it's for a task or a pipeline, it's reusable. So you can reuse this task or a pipeline in any use this task in any pipeline you define. Coming to pipeline, so pipeline is nothing but a graph of all the tasks. So you can define all the tasks in your pipeline, and you can also decide the sequence of running of this task. It can be sequential or or concurrent. And also, like when I say this, you can decide after the first execution of the task, the second task should execute. You can also use the input output of first task as an input for the other task as well. So workspaces is nothing but it's like volume of the file system that needs to be provided to the task or the task run or the pipeline or pipeline run. And coming to task run is nothing but it's a reference or an invocation to the task. So when I say this, when you create the task run, it does nothing but the execution of the logic or the script you have written in a task. And similarly, the pipeline run, it's the invocation of a pipeline and it executes the pipeline which you have defined which you have defined. So for a basic knowledge, I would say like task and it's like a class and object relation. And yeah, that suffices the needs for Tecton as well. Okay, coming to Tecton pipeline 101. So I'll not demo how pipeline. I'll run a pipeline and a pipeline run, but I'll not show like what Tecton pipeline is. I'll just show the YAML. So if you see the YAML of a task, it has the API version, the kind is task, and it has spec. Under the spec, if you see, we have workspaces, params, results, and steps. So steps is nothing but if you see in the steps, we have written the script which it's the normal scripts which you can write in your bash scripts or shell scripts. And next is on the right side, if you see, we have defined a pipeline. And in this pipeline, we have a field in the specs called as tasks. So in this task, we are using the reference of the task which we have defined. So this task, if you see, there are 2 tasks in a pipeline. And next, if you see on the left side, we have a pipeline run. And in this pipeline run, we are referring that pipeline which we have defined. So when you run this pipeline run, it will execute the first task, that is the fetch secure data. And once that is completed, then only it will execute the second task. And we have defined that run after key. If you see below, that is task ref, right? All right. So this is how just the Tecton workflow is. So we define a pipeline. Inside a pipeline, we define task, the number of tasks which we want, the order of the task of execution. Next is you create a pipeline run for that. And when you create a pipeline run, it will create automatically the task runs for which you have defined in the task. And once a pipeline run is completed, under the hood, at the start, as I said, it abstracts the Kubernetes resources, right? So it creates the pod. Ultimately, it creates the pod, and you can you can see the logs and all for like you see how you see the logs of the pod. Similarly, you can see the logs of a pipeline run or a task run. All right. Coming to the next slide. Now we are good. We know Tecton task, Tecton pipelines, how it is. So what are the challenges of a Tecton task? So if you see in Tecton task, it's a serial execution. You cannot block, or it is not blocked at some time, or it doesn't wait for any human intervention or in human input, right? That's one of the challenges which we face with Tecton task. Next is like for running any task run or a pipeline run, you need the Kubernetes resources, right? Ultimately, it creates a pod and it performs some validation checks, and it has it performs external operation and all, right? So these are the challenges which we have with Tecton task. So how do we solve them? So we have something called something called as custom runs, custom task, and controllers. And let's go and see how they are and how they solve our challenges, right? So when I say custom runs, so custom runs is nothing but a custom resource, and it is created when you create your pipeline, and that is while the execution of the pipeline, and it refers the custom task as an identifier. We'll see what is custom task in the next slide. And once it reaches the reference to the custom run, the pipeline is blocked. It waits for the updation of the status of the custom run. And once the status of the custom run is updated, then only the further execution of the pipeline will continue. Until and unless, till that, the pipeline will be completely blocked. And who updates those status of the custom run is nothing but the custom task controller, which you have written, right? So next is custom task and controllers. So custom task is nothing but a CRD again, which is defined by the user. And it has similarly like the API version, group, kind, and the spec. And the logic for the controller logic you have is defined by the user. This custom task name can be used as an identifier in the controllers you want, and it can be referred in your controllers. And finally, the user needs to write a controller that watches this custom runs. So in the informer, I'll show you the code how we added that in the informer to watch the particular custom run whenever the custom run is created. And finally, when the controller logic of the custom task updates the custom run status, then the further execution of the pipeline will continue. So just an example of how custom run is created. So in the example YAML, if you see, we have referred the custom task. So here the custom task kind is example. So if you see, you could define as same, like you define a task ref, which I've showed in the previous slides. So it has the API version, kind, and name. So the name is the custom resource name. The kind is the example here. So once it completes this step, then only the execution of the further pipeline will continue. All right. I hope I didn't bore you here. Okay, let's get to the demo side. How custom run solves the problem here actually. Okay, before I go to the demo, I'll just show, is the font visible? Oh, nice. Okay. So here is the controller code. So if you see, it's just this is just a normal controller. So if time permits, okay. So if time permits, okay. Is it fine? Oh, okay, nice. Okay, if time permits, I'll show one more demo of manual approval. But for now, I'll show how you refer a custom run in the controller. So if you see here, so this is the controller main logic. And if you see this part, I guess you just knew about the informers part, right? In the last talk. So this is how we refer or add an informer to the custom task. So whenever this custom run is created, the event will come to this controller because you have referred that custom task in your pipeline, and the reconciler will get an event and it will continue with the further business logic which you have written in your reconciler. So we have a example where we are adding a custom task called as wait, and we are adding a timeout. We are adding as a param, that is a value which says wait for 5 seconds and then only continue the next task. So this is how this is just a basic reconciler for wait. So if you see here, we perform some validations, like if the customer ref is nil or not, then we check the name of it, we check we get the param, we get the value from it, the duration of it, and finally, if you see here, if there's any error, we just mark the custom run as failed. So when we mark the custom run as failed, it won't execute the further pipelines, and the pipeline run will be failed at the end. Similarly, if you go ahead, there are certain checks. If the timeout is exited, it could not complete for some reasons. At that time also, we just fail the custom runs. And yeah, so this is just a code part, just a brief overview of how code is for the custom task controller. And yeah, just give me. So, okay, so these are the two tasks which I have. So the first is fetch secure data, and the second is just print the data. So these are the two tasks which we have. Okay, I'll increase the font. Then we have this pipeline. If you see this pipeline carefully, the first we define as The first task is fetch the recipe. Second is, so here comes our custom task. And so it runs only after the first task is completed. Until that, it won't start. And if you see this, we are defining our custom task. So the name is wait. The kind of that custom task is wait, the logic which I showed you. And the params we provide, where the duration we provide as 5 seconds. So once the first task is completed and it comes to the second custom task, the pipeline will be holding for 5 seconds. It won't continue. It will be blocked for 5 seconds. And as soon as the 5 seconds are done, it will just come and execute the next sequential task which is defined. So that is print recipe. And yeah, that's all in the pipeline. We don't need to define anything. Okay. So what I'll do, okay, I am not able to see. I want to go to this. No, I want to go to the second. Okay.
Yeah.
Yeah, how do
You
I
can
find-
hide this actually. Go to more. Hide video panel or something. No, wait. See, hide.
Okay, I think. Okay, that should be fine. I guess.
Man, this is all.
Okay. Okay, that is fine.
And zoom in a little bit if you
Yeah,
can
yeah.
on the terminal as well.
Yeah, yeah. That's what I do, but this is not going. Okay.
Control shift plus. So,
Yeah.
oh, yeah.
Yeah, I guess this is nice. Okay. All right. So I'll just create the namespace and I'll set the kim config. Okay. Now I'll just go ahead and create the YAMLs. So on the right side, I'll start the logs of Kubernetes custom task controller. So you can see the logs, like once the custom run is created, you'll see that the custom task controller will receive the event and you'll see the logs for that. Okay. And on the one side, you'll see we'll keep a watch on custom runs as well. So I'll just go ahead and I'll start. Okay, so if you see, the custom run is created and same side, the wait custom task was triggered. And finally, once the duration has elapsed, it got the pipeline execution got hold, and finally it executed the second task. So this is how the custom task controller works. So just a second. I just want to confirm if we have time for the next demo, else I will go with the question. Okay, thanks. So, all right. So I'll go to the next demo. So in the next demo, what I'll do is, now you saw we just wrote the controller logic, and in the controller logic, in the reconciler logic, we said like wait for 5 seconds. Now let's say there's a requirement that user needs to provide the input, and then only the execution of the further pipeline will start, right? We'll see. I have the CRD controller installed for that. I'll just show the demo. The code part, if time permits, I'll show, else we can sync offline for that. Okay, this is something. Okay, the task is same. We don't need to take that. In the custom task, if you see, I have defined something called as wait. The custom task kind is approval task, and the params. So when we say we need approvals from the users, for now we are considering as the Kubernetes users, the Kubernetes logged in users. So you can define the usernames in the params called as approvers. So once you get the approvers from them, then only proceed. And also when you say, like, let's say you've provided two approvers in the params, but you need approval from only one user. So that means, like, once you get the approval from only one approver, just execute the pipeline. Until and unless it doesn't matches the approval count, it will block the pipeline. And also we have default timeout for them. And also, like, you can provide the timeout based on your requirement as well. All right, I'll go to the demo again. All right. So if you see on the right side, okay, set the context. I'll see. Okay. Name is required. Okay. So just give me a second. Okay. So if you see here, okay, so the pipeline run will be started now. And okay, it is stopped now. It is halt. And if you see the, so if you see the custom run, it will say it has started the custom run. The status of it is unknown because you don't have anything now. And now we have written a custom task controller that is approval task, right? So we have this called as approval task. So you'll see this approval task. So for now, I'll just edit the YAML as user1. You can see the YAML of it. So if you see in the YAML, it says the input is pending for user 1, and similarly the input is pending for user 2 as well. Okay, so I'll just edit as user 1, and I'm using the -as command from Kubernetes because I haven't created users. I'm just using a kind cluster for now. Okay, so I'll edit the YAML for user1. So let's say now the question comes like, what if user1 has started, user1 has approving the approval task for user2. So we have performed validation checks as well that, so like other approver cannot approve the task for other approver. So you just need to provide approve here. That validation checks are also done. Like you can't provide any other string, only you need to provide approve or reject. Okay. So it got edited. If you see the approval, okay, I have CLI. So if you see the pipeline run got unblocked and then it executed the second step. So if you see the approval task list, it is approved, right? And you can also, so I've just written a CLI for that. Okay, I can't copy that for now. Okay, wait. Sorry, this Zoom is annoying me. So if you see, we have a describe command for that as well. So it says like the approver response is from user 1, and the number of approvals required were 1, and the pending approvals are 0. And finally, the status of the approval task is approved. And finally, if you see the custom run now, it will be succeeded. And that's why it unblocked the pipeline. Okay, coming to the slides. This was the part of the demo which I had. And okay, any questions? Oh, yeah.
So as a business owner, I wanted to understand the real-time business case, number one. Second is,
Sorry,
how
sir.
can we integrate this Tecton in existing Kubernetes environment? Is there any possibility?
So sorry, I didn't get the first question. Sorry.
First one is adoption rate of Tecton.
You mean how do we convince
Yes,
to use Tecton,
yes.
right? Okay. So
And second one, it's adjacent to this. Number one is the adoption rate, because I've heard it very first time. Maybe I heard the term, but looked at the scenario very first time. And how can we integrate this Tecton? Either it is a utility or feature, whatever it is. So how can we, integrate this with our lot of existing and Kubernetes environment?
okay, you mean the first part is what is the adoption rate? I don't think I can answer you to the precisely for that, but since it's an upstream project and it's growing well and it's pretty matured now, it has V1 APIs of Tecton as well. And there are features coming on, new features coming on. For example, there's a new feature called a step action, and there's something called as caching as well. So adoption rate, I would say like it's since the features which it provides, for example, the flexibility, the reusability, and the integration with any Kubernetes cluster, it's I would say it's not that difficult, because the only struggling part I would say is like understanding the Tecton YAMLs, how to write that. I don't think I would answer that correctly for you, but so regarding the integration part, I would say like to test it on any Kubernetes cluster, you just need to install the YAMLs. And for usage perspective, it's like you have the documentation's easy. And so for now, if you see the integration part, I was just using it on a client cluster. So let's say if you want to integrate it with GitHub or something, it's you just need a cluster. And there's something called as pipeline as code as well, where it creates a .tecton folder. And once you push your code, and if you have a cluster, and it creates a pipeline run, and automatically it will start the CI, and it will perform some checks. I am sorry if I'm not able to answer you correctly for that. Okay, thanks. Or maybe we can sing offline for that.
Yeah, actually, my question was the same as his first question. Means like, what are the business use cases where a user want to use, means like will want to use a Tecton? It's like a real world use case means.
So it's a yeah. So real world use case, it's like it's a developer platform. So if let's say you're considered a developer and you write the code, so the ultimate thing or the ultimate goal, it's easy. It makes the life of the developer easy. So for example, you have written the code. You don't need to, once you have YAMLs and all are configured, you push the code to the repository, your CI will be started automatically. You don't need to have manual checks automatically yourself. You just need to have, let's say you have unit some tests or not. In the CI, you can see the tests are running or not. It's just like it will run all the pipeline runs in your CI. And you have something called as, let's say if you want to, once the PR is merged, right, you need to automatically deploy it. There's something called as event listeners as well. So once the code is merged, automatically the pipeline run will be triggered, and it will, you can define your pipeline run. And based on, so for example, I showed you the example. So for example, I showed you the manual approval second demo, right? So let's say you have a CI in your CI, right? And in your CI, you have in the pipeline, you have three tasks. Right? Let's say first is lint, check the lint. Then if the lint is passed, build and then deploy. So every time you don't need to deploy, right? So let's say the first two tasks are done. Third, you define your custom task, that is manual approval task, right? Once it comes to the state, you'll say, I want to approve or reject. Once you approve that, then only it will continue the last step, that is the deploy part, right? Until and unless it won't, it will block the pipeline in that case. So yeah, I think the adoption rate, I need to find the answer for that, but I hope, did I answer the question correctly? Yeah. So you don't need to worry about your CI/CD part. You just need to define the pipelines for you, and it will automatically solve the problem for you. You just need to write the code and push it to your repository.
Hi, this is Sanjay here. My question is, you mentioned that these tasks run in sequence, I mean, serial manner. Most of the CI cases where we currently see might have independent tasks to run. So is there any provision to run them in parallel than serial?
Yeah. So when I said task runs in sequence, but in pipeline, you can define pipeline can be run in a sequential and parallel way. So if you see the slide, so if you see this side, you have two tasks, right? And you say like run after is the keyword if you see for the second side, right? So this means like this gives a sequential order. But if you don't say run after, in that case, both tasks will be running in parallel. Yeah. All right. That's all I had. Just one last slide. So this was the reading material. I'll share the slide if you want. And yeah, be friends with Tecton. All right. That's all I had. Thank you so much.
Thank you so much, Praneeth. So now that we've come up to the break point, I'd like to mention that the snacks are ready behind us. We'll take a short, like 10 minutes.
Hello, everyone. One more minute. Okay. Hello, everyone. Welcome. Let's start off. So my name is Surya Balakrishnan. I'm from Cloudera. Today, I'll be talking to you about building a data engineering platform on Kubernetes. So a few simple questions, just so I know which areas to focus on. How many of you have heard of Apache Airflow? Okay. How many of you have heard of Apache Spark? Okay, better. How many of you have heard of Kubernetes? Okay, thank you. Okay, let's get started. So a brief summary of the agenda. First, we'll talk about what we built. I'll demo it a bit. Then I'll talk about the architecture and a few technical details that I thought were interesting. So to understand what we built, you have to understand our business first. So what is Cloudera? So Cloudera is a big data company that offers a product called Cloudera Data Platform. We're in the business of solving enterprises their entire data lifecycle needs. So what does a typical data lifecycle look like? So first, a company or something would have different sources of data. They would ingest it with using some streaming operation. They would clean that data up using data engineering, and they would store it in a data lake or a data warehouse, from which they can go and access it later. Once that's done, for some use cases, if they want faster access for the data, they might use an operational database. And once that's all done, they would do some machine learning or analytics to get some real value out of that data. So to help companies with these problems, we have a suite of products, 5 products. One is called Data Flow, which is built on Apache Kafka and NiFi. Our data engineering product built on Apache Spark and Airflow. Then our data warehouse product built on Apache Hive and Impala. Our operational database product built on Apache HBase and Phoenix. Our machine learning product, which is a Jupyter interface, but it's a cluster that can run TensorFlow and PyTorch scalably. Now, to support all of this, we have this one common metadata layer called Cloudera SDX. That's a sort of shared data experience. So regardless of which product you're talking to it from, it feels like you're talking to the same data. Now, all these new 5 services are they run on Kubernetes. Earlier, we used to have our our past product offering was on on-prem, like bare metal machines, and now we have sort of moved to Kubernetes. In this talk, I'll double click on how we build the data engineering offering. So as I mentioned earlier, Cloudera is like heavily built on a lot of open source technologies. We have committers and founding members from a lot of core big data Apache products like Hadoop, Spark, NiFi, HBase, Airflow, Ozone, Phoenix, Unicorn, just to name a few. So the two core technologies I'll be talking about today are Apache Spark and Airflow. How we use Spark is a very widely used, or the most widely used data engineering product today, used by a large number of data engineers. And we'll talk about how Airflow complements it to help you really build these data engineering pipelines and orchestrate your pipelines. So I'll quickly show you the product, then I'll explain the details underneath. So this is, it's called CDE. We have these services on the left. Each is one Kubernetes cluster. Within a particular service, you have these virtual clusters on the right. So each virtual cluster, you can think of it like a Kubernetes namespace. Now, the reason we did this is so that a particular cluster can be shared amongst different teams in the company. Different teams can enforce quotas, say that, hey, this team can only use so much, the other team can use so much. So once you've gone ahead and you've created your clusters and virtual clusters, we have a few concepts or things that you can play around with on the left. The first one I'll talk about is called a session. So in this page, you'll select the virtual cluster you want to interact with. And once you're there, you can create a session, but I'll just for the sake of time, I'll go ahead and interact with an existing session. So a session is basically a long-running Spark cluster that sits there. You can go ahead and submit your Spark code to it, see the results, and then keep iterating. Video, I can't zoom in much. Okay. So yeah, you can keep iterating. So the typical data engineer flow of their entire process is they'll write code, check it out. If there's some error, fix the error, run that same code again. Then if the output is not correct, they'll fix that, and then they'll again run it. So here we give some sort of interactive interface for them to sort of run line by line code and then see what's happening. So one very commonly used Spark operation is spark.sql. Through Spark, you can sort of run these SQL queries. Here I'm printing out stuff from this demo table. Let's see what it says. Welcome to the meetup. Now, the same thing, we have this other sort of form factor of these sessions called Spark Connect. Users of Spark might be familiar with it, but essentially what it means is you can keep the cluster running here, but from my local machine or any machine that has network access to my cluster, I can go ahead and run code against it. So I'll go ahead and connect to my Spark cluster here. And once that's done, I'll run the same code. Now, this has some added benefits that you can use Jupyter and any IDE of your choice. So you can sort of have all the benefits of Jupyter, etc. Let's just see it print the same thing. So usually once a data engineer sort of creates their code or something, they come and they create this sort of a job. So what they do is that same production ready code that have interactively built, they come, they paste it here. Here you upload your application file, pass in any extra arguments you might have. In the options, you can pass in any supporting extra files. And then here, I'll explain what it is in a minute, but you can specify the number of executors, the memory and CPU for each executor, or what size of cluster you want. And the interesting feature is usually after that, you can schedule your certain jobs. So data engineers, some jobs you might have to run ad hocly, but most of them you have a schedule out. Like say, before the start of the week, I need this data process. So Monday at 12 a.m. or I go ahead and run this job, and you have a certain set of schedule set. So this lets us do this. And we do this using a sort of Apache Airflow under the hood, but I'll explain what that is as well. So we also, similar to Spark, we let users upload and run their Apache Airflow code. Our entire thing is to become a managed Apache Spark and Airflow offering. So the user can go ahead and upload the code they've already done, or we let them go ahead and through a drag and drop editor, we let them sort of create steps, link the steps, and then sort of run. So in this simple hello world example, I just print hello world. and then I go ahead and run an example job that I've already defined earlier. Now, once you've triggered it and you start to run it, you can sort of monitor the same in the Airflow UI or Spark UI. Moving back. So just double clicking and describing Spark for the people who don't really know what it is. So as you saw, you can sort of run SQL operations, but Spark is much, much more powerful than that. It interacts with this data structure called data frames. So you can create these very complex data engineering pipelines to process data and using Spark. It has a sort of master-slave architecture. You have this one brain program called the driver, and then you have these worker nodes called executors. So the driver basically, let's say any operation is given, it goes ahead and creates this graph of steps that need to be executed in order. And then it goes ahead and distributes those steps to the worker nodes. Worker nodes go ahead and actually do the heavy lifting. And once they've done, they communicate to the driver that, hey, we finished. And the driver goes ahead and consolidates the program and all the results and gets the results back to the user. Now for one analogy I like to think of, if you've used pandas, it's like pandas on steroids. So like just lets you do exactly what pandas does, but on larger amounts of data. Now, why and what is Airflow? So in Airflow, you can create this Python code, and that gets converted into this graph of sorts. So you can have these dependencies. This step here will only run after the previous step has finished. These steps here will only run after the previous step has finished. And this lets you create this execution graph, and that is pretty powerful. So for the data engineering pipeline, usually there are some trigger events. Like for example, when new data gets loaded into S3 or something like that, then you can have trigger events that sort of trigger this graph, and then they go step by step. If some part of it fails, you could say, hey, do something. If it goes successfully, do something else. Now, the real power of Airflow is the rich ecosystem it has. So each of these nodes could be doing some complex operation. So for example, there's a large amount of community support for these operators and plugins. You could either interact with AWS, interact with GCP, interact with Azure. Each of these nodes could be one of those. It could be interacting with Kubernetes. Anything that's automatable, there's very likely an Airflow plugin already for that. And so these two things put together make it an extremely powerful tool to create these pipelines of stuff that go ahead and do step by step. Now you guys might ask, hey, I'm here to learn about Kubernetes. Why are you telling me all this? So essentially, the aim of this talk was today that we have some domain-specific problem of data engineering. How have we built something on Kubernetes to help enable that? So this is a very high level of the entire architecture I showed you. You have this one Kubernetes cluster called the CDP control plane running on Cloudera infrastructure. You have one small service called CDECP, we call it, that runs here and that sort of manages the clusters on the other side. Now, within a customer's cloud account or on-prem infrastructure, we go ahead and we create and manage these Kubernetes clusters. Now, why this split, you might ask? Because all enterprises are very concerned about data security and privacy. This way, we never sort of interact with the data. All the data is on the customer's account. We just sort of manage these clusters from afar, and we run software on their cluster, and the two together do the entire life cycle. So just double clicking a bit into each CDE cluster. So that service I spoke about on the left side of that screen, that's this CDE cluster. Within that, you have these sort of common services called like Unicorn, Prometheus, Calico, to name a few, and Ingress, etc. that are there. Each virtual cluster spins up a namespace. Within it, we have a few common shared services like Airflow API and our CD API. Anytime a user goes ahead and triggers a job or any workload, a new Spark or Airflow cluster comes up as pods, and then they go ahead and do their work. To store data and logs, we use S3. Metadata we manage in RDS, and all the user files are sort of stored in EFS. Now, since we're multi-cloud, sort of we run on AWS, Azure, and on on-prem deployments, you can take the corresponding versions of these for that. So CD is built on top of a lot of cloud-native components. So Apache, Airflow, and Spark I briefly spoke about. So since they run on Kubernetes, that's very useful for us. There's this another core open source offering we use called Livy. So in case you've not heard of it, it's basically a REST API that helps you manage Spark clusters and makes our job a bit easier. There's another component called Unicorn, which I will dive to in a little bit. But the fact that we're running it on these Kubernetes cluster gives us a few advantages. One is we can mix version deployments. You can have a Spark 2 cluster and a Spark 3 cluster within the same Kubernetes cluster. In the on-prem world, this would have been very, very difficult. And we get some of the benefits of the clouds that you can easily auto scale as your your cluster is not over provisioned. Whenever you run jobs, that's when you get new nodes. Cost saving benefits or features like spot instances, etc., could also be used. We make heavy use of Helm. So since I just briefly mentioned that, hey, we run on multiple different form factors, Helm makes it easy for us to have one single code base and have all the configuration on the other side, so that we just tweak a few parameters and then the workload sometimes doesn't know where it's running, but it's wherever it needs tuning or tweaking, the Helm takes care of that. It also makes upgrades simple and other features easy to manage, because you have a complex, different customers have different privacy, security, etc. requirements. So the feature set or the feature matrix, there's a slightly long list. And so Helm makes it easy to manage from a code perspective. Apart from that, we use Fluentd for logging, pod loggings, everything, all logs get sent to S3 so that customers, for troubleshooting purposes, they can take it later. Apart from that, even the workload logs, right? You run some program, you see the logs for that. Similarly, slightly different, but a similar process gets sent to S3, and then we go ahead and read from there. We have Prometheus and Grafana for metrics, and then we have these real-time dashboards that customers or admins of the cluster can come and check if, hey, is everything healthy? If something's not healthy, what the heck do I do? Do I go ahead and increase the node counts, auto scale limits, etc.? We use Calico and Istio for as a service mesh. There is one internal project we have, a common provisioner. Like I said, we have multiple different parts of the data lifecycle. Now, if each team had to go ahead and write their own code for provisioning Kubernetes or interacting with Kubernetes, that would be, you're doing the same work multiple times. Instead, we have this one common piece that has some interesting technical challenges. My colleague will try to schedule a talk someday later. They'll come and talk about this, but that's a pretty interesting piece, and I'll let them talk about it later. So now, in a slight parallel, some of the challenges of scheduling for these Spark or batch workloads. So simply put, the default Kubernetes scheduler does not know about applications. You go ahead and create stuff, pod by pod, it will go ahead and create. And then as soon as that pod is schedulable, the pod gets scheduled. But for Spark or some other applications, the entire application needs to be scheduled before it gets to start. In the simple example of Spark, I said there's that driver and executor programs, right? Until a driver and a minimum number of executors spin up, the Spark doesn't start doing its work. So what does that mean for us? So for example, if we have a requirement of 4 pods and only 2 of them can sort of get scheduled, these 2 pods will they'll get scheduled and they'll be sitting there and waiting. Now, then that's a waste of resources. They could have been consumed by someone else or something like that. Until one of these other running jobs get finished, he will never even start running. And in a very bad situation where multiple jobs are in these sort of like semi-pending states, you could choke the cluster unnecessarily. So to solve these problems, a few years back, from within Cloudera and with the interaction with other folks from the community, we started off this project called Apache Unicorn. So as I said, the simple problem of the default Kubernetes scheduler is you have one single queue. All your pods go there. You can have some policy there, and then they get scheduled one by one. But as you saw, we need the default scheduler to know about apps entirely, which is like a set of pods. So how do we go ahead and schedule apps? And then can we go ahead and enforce quotas, say that, hey, this team only uses this much, the other team doesn't use that much. Can we do that with some sort of hierarchy of queues? And then can we go ahead and maybe even make some more node level optimizations? I'll explain in a second. So the 2 key concepts in Unicorn are queues and apps. So apps are basically a set of logical grouping of resources, could be pods, etc. You group them as a single app, and queues are sort of very similar to the default queue that's there in the Kubernetes scheduler, but you have a hierarchy of queues. So a child queue, parent queue, etc. I'll touch upon it in a minute. So this really helps us solve in the gang scheduling problem. So what it does is Unicorn goes ahead and creates placeholder pods. So until I get my space for 4 pods, I won't really schedule my application. What does that mean? There is no waiting, there's no resource wasted, or there's no pods that are in a pending state and choking the cluster. And those queues I spoke about, they are queues of applications. Within the queue, I can go ahead and schedule, or I can create these complex scheduling logic. One example would be, I could say first in, first out, whoever comes in first runs first. Another thing could be fair scheduling. What I mean by that is two applications are running at the same time. They get a reasonably equal share of resources. Now, another interesting thing is these node level optimizations I spoke about. So you have these node sorting policies. Now, since we run on private and public cloud, the requirements are sort of different from each. What do I mean by that? In private cloud, you sort of want a reasonable distribution of your pods amongst the nodes so that if there's a spike or some sudden spike, your pods can handle it. In the public cloud, your entire main concern is cost. How can I reduce my number of nodes? How can I squeeze everything into one node so that the number of nodes is different? So for that, the algorithm that there is called bin packing. Everything is squeezed into a node so that these underutilized nodes are removed. While the other, for the private cloud, we might say we have a fair sharing sort of sorting where it's all equally distributed. Now, this is what the tree of queues I spoke about. So at its root, Unicorn will have, okay, this is the root and this is the amount of resources I have totally. Unicorn, you could register a namespace with Unicorn, and so some stuff will not be registered in Unicorn and Unicorn won't technically know about. So any pods you schedule in those non-Unicorn namespaces, Kubernetes default scheduler takes care of it. But let's say, so its root quota is calculated as total amount of the cluster based on the number of nodes minus the actual usage used by these pods. Within a particular root, I can go ahead and create sort of these child queues. For example, here I have this limited queue with 50 GB and 50 CPU of memory. The root queue has 75 and 75, and I have this unlimited queue which has sort of no policy set. Within the queues, I can have these sort of first in, first out or fair sharing principles so that all applications and pods within that follow that order. Amongst queues, I can have sort of a fair sharing system. What do I mean by that? Let's say unlimited has not had any applications running yet, and limited is running at full capacity. He will occupy all 50 and 50 GB and 50 CPU. But let's say unlimited starts running. It's not fair to him technically that, hey, he's using 50 and I will only get 25 left. So then Unicorn does some rearrangement so that each gets some roughly half or roughly fair amount of quota. Now you might say, okay, these are only few these scheduling policies, but using Unicorn's extensible system, you can create your own scheduling policies based on your requirements, and those can be plugged into the Unicorn scheduler. And now one common question that is asked is, hey, these hierarchies seem a very bit complex. How the heck do I manage them? How the heck do I debug them? So usually in companies, how they do it is they have some sort of logical ordering. So root will be the entire company. Unlimited would be one organization, sub-organization. Limited would be another organization. And you can say that, hey, this organization needs this much, that organization needs this much, and then you can sort of order it accordingly. But it is a difficult problem. So briefly talking about the architecture of Unicorn, you have this core which doesn't know where it's running. It doesn't know it's running on Kubernetes. It deals with Unicorn concepts and it takes care of the scheduling decisions. You have this Unicorn K8s shim that converts Kubernetes concepts into Unicorn concepts. The reason this was done was so that Unicorn can run regardless of the cluster orchestrator it uses. So like Hadoop Yarn or Mesos or any other cluster orchestrator, it can run over there. You just have to sort of replace this shim. The interest of time, I will skip a few topics. Okay. So another, like most common deployments, we use Prometheus and Grafana for monitoring. But we've faced challenges with Prometheus memory in the past. Now, my colleague has done some interesting work. Now, when you face memory challenges, the very simple solution is, let's just go and increase the memory on that pod. That should take care of it, right? But it's like a vicious cycle and you can't keep on increasing memory forever. So what he did is, the way Prometheus operates is based on the number of time series it's calculating, the memory usage increases. And time series is like, it's slightly complex, but okay, it's slightly complex, but you have this sort of, as you have these combinations of labels and metrics, the number shoots up. So, and another problem we have is components like the code written completely by us, like the CD APIs, we clearly control all the metrics. But let's say we are also offering managed Apache Spark and Airflow, right? They'll be exporting their own set of default metrics. So they might be overloading the system without us choosing to. So what we've done is we sort of ranked the entire number of metrics by their cardinality, and whatever we thought was not necessary for the user or admin at any point of time, we sort of removed them. Now that helps a bit, but you still have some more tweaking to do beyond that. So what else did we do? There are these two things we did. There's basically this head block size you can sort of tweak. We tried a few different parameters till we got to a reasonable result. Another thing, there's another parameter on how often Prometheus sort of flushes to disk. That also we sort of tweaked. But still, today we are happy and we're like, okay, it's running fine for now. But let's say suddenly the usage again scales, right? Because any new system you add will sort of add new metrics to the system, and it will be a problem we might face again in the future. So how do we sort of solve that? Now, recent release of Prometheus, there's sort of this very interesting, there's this talk, KubeCon talk, where he sort of reduced the memory usage of Prometheus by half by doing some very technically interesting stuff. Do check that out. But one thing is sort of simple solution is, hey, upgrade Prometheus. Now that there are like few other things that I could go into, but I won't go into too much detail here. Another problem we have is it takes us sort of time to decide how much CPU and memory should we give to any deployment. So what does that mean? You start off, you say, okay, I think this is the requirement. Then you do some load testing, internal load testing, assuming that customer workload will be like this. Then you find out that, hey, it matches the request, this thing, and then you're like happy, and then you go push to production. But it's like still a painful process. You have to do trial and error, try this, and then actually force the system to break and figure out where it's breaking, and then you sort of tweak it. Another simple problem here is code not written by us is sort of deployed. So you have Prometheus and other things which are like their code not fully controlled by us. Our code, we know exactly what the memory footprint is like, where do we tweak stuff exactly. But you can't expect any team to go ahead and know the ins and outs of an open source system, right? So how do we go ahead and tackle that? There are a few approaches we're saying. Yeah, one thing I forgot to mention. Prometheus, we are looking at horizontally auto-scaling, but the problem is there it's slightly complex to, Prometheus was never built to horizontally auto-scale. You can do it by setting but you have to set the number of replicas at the start of creation. You do this data sharding approach using Thanos, but the problem there is sort of when you create the cluster, you need to know that, hey, I will have 3 replicas or 3 things running, this thing. The problem with that is you want your cluster to grow as the scale of your cluster grows. If for a smaller usage, you don't want it to be running at 3 pods just so that it causes extra cost for the customer. You need it to scale with load. So that's one of the reasons there's this sort of alpha feature. I'm not sure if it's GA yet in Kubernetes called virtual pod autoscaling. Based on the actual usage by pods, it recommends that, hey, you can go ahead and increase these memory or resource CPU requirements. And once that's done, there are sort of 2 ways. There's one in-place upgrade where the pod sorts of increases, but it doesn't get restarted, which is a nice way, depending on whether the code can handle that. In case the code can't handle that, you have to force a restart, which is better than an out-of-memory kill, but it's still a sort of something you have to handle properly. I think that's mostly it. Any questions?
Hey, so we have started the journey on using EKS to do our data engineering work. Primarily we use EMRs, but the concept remains the same. So
correct me if I'm wrong, you're shifting from EMR to your own EKS service?
Yes,
or?
EKS service. So we use EMR on EKS and then we run our workloads.
Okay.
We use Airflow, Kafka, and all the other integrations that are required. One challenge that we have is when we pull the data from S3 to the service, right, it is very slow.
Okay.
Right. So that we are not able to solve. We are trying to do a lot of VPs, PVCs using, the technologies that AWS are providing. Is there any recommendation that you have? How do we preload some of the things when we know already? Like Unicorn does provide us some bit of understanding on what application really is. So can we preload some of these things?
Okay, so it's not Unicorn's problem technically, because Unicorn's this thing is to schedule the pods. So the data load problem is slightly different. Once the pods are scheduled, your entire thing is Spark executors are there. How do you get data into them fast? Right now, some context, we are sort of from that Hadoop world. So we have like this tight integration, and Hadoop on S3, we've sort of optimized. So if you do HDFS, file reads, etc., for us, it's reasonably fast. But some customers like you or might also try directly reading from S3. Have we done any optimizations on that part? I'm not aware. Let me check and get back to you. Yeah, it's a complex problem with interesting things to talk about and think.
Hi. So regarding NiFi, right? So you can hear me?
Yes,
Yeah,
yes.
yeah. So I was associated with a product with IT Ops. So there we need
Sorry,
to.
could you keep the mic?
We have to ingest the data from various monitoring tools, right? So from customer to customer, the data volume changes. So many times there used to happen, the ingestion fails, the NiFi is down or something. There's a cluster. The team used to change the thresholds and the queue limits and the processors. I'm not very familiar, but the team changes that. But quite often it dies actually. And is there anything that can be done generally better, even with cluster and then queue? Because definitely based on the volumes,
I see.
it goes off.
So correct me if I'm wrong, you're offering a product that's built on NiFi, and sort of when you're trying different data volumes, sometimes it fails.
Yeah, it's a SaaS product. Data comes into through NiFi, multiple tool data ingestion, and there's a what you mentioned, Kafka is there,
I see.
and further down everything. Yeah.
My recommendation, again, it's a slightly complex problem. Until I see the log, see which components are failing, it's a bit hard for me to tell. So when does it exactly fail? Does it like in different data ingestion also, there's different types of data you're ingesting, no? So you have to figure out where is it failing more, where is it failing less, what is the reason. NiFi tuning is also a different, could be a different talk entirely on its own, but it's not a straightforward problem, and you need a much more details to actually clearly tell. Because it could be very different, because the symptom is basically it's failing. Person comes and complains it's failing, but why is it failing could have like 3 or 4 causes, no? So
Right.
Thank you.
Thank you so much, Surya. We can take one more question.
Thank you. Hi, I am Ishwar. So these unicorn scheduler, Fluent Bit, or Prometheus.
Sorry, could you keep slightly closer?
Okay. Is it fine now?
Much better,
Okay.
much better. Thank
So
you.
all these add-ons we deploy into the same Kubernetes cluster, right? So where we run our workloads. Is there any feasible way that we can separate the monitoring tools or the support tools into one cluster and actual workloads into another cluster? But still, these two clusters communicate and give me the monitoring things on the separate cluster.
Technically possible. Side note, we did do that in the past. We used to have one separate cluster for Prometheus and Grafana. But the problem is, again, it's a trade-off, right? A cost. Customer will say, why are you keeping another cluster just for monitoring and this thing? Why not put it here if it's tuned well enough? As long as the system works for a satisfactory performance, that's fine. Now, again, it depends on load, etc. Which components fail? When do you scale what? So here right now, we're at an okay and a happy state for now. But let's say 2 years again, in the future, something else breaks. What do we change then? It's completely possible. We have done it. You could have 2 clusters doing 2 separate things, export the metrics from A, consume it in B. Should you do it or not is, again, case specific. And these are complex systems. Again, I don't like giving that answer, but
okay, thanks. One last question. So
please go ahead.
These Spark jobs we submit, right? We select the memory, driver memory and worker memory, and right. So sometimes I'm not aware, right, how much memory it requires for my Spark job to run it, or maybe the RAM size, or maybe the selecting things. So is there any recommendation that it can provide Cloudera, right? You selected extra memory, but it is not required. This is finished too early.
Okay. Spark does something, at least I'll talk in my context. Spark does something smart in the sense that it has this feature called dynamic allocation. So even, I'm not sure if in the video, you specify a min and a maximum executors. Okay. You say 1 to 20. So what that means is Spark will use as much as it needs. So if it needs only 4 executors, it will run only 4. But Spark will smartly decide that, hey, I need this much. I can request 20 at max. So for us, in that sense, that helps. But let's say you have some other application that's not Spark. Your question is, how does the system decide sort of, let it give me some intelligence to decide how much CPU memory to put. That's similar to that VPA problem I explained. You have to understand the code. You have to figure out where is memory being used, where is CPU being used, how do I tune it, etc. So it's again application specific and doable, but it's not straightforward, sort of.
Thank you.
Oh, okay. So I'll be here only. These are my friends from Cloudera. So if any questions, anything interesting, please do come reach out. This is just our system. There could be a lot of improvements. You feel that, hey, you're doing something that's not nice. I have a better idea. Please do come tell me. I'll be very interested to listen. So yeah, with that, I'll end the talk.
Thank you so much, Surya. So our next talk is on how do you influence Kubernetes schedulers' decisions, even though the default scheduler, does pretty much does your job, right? How do you influence it to do scheduling in certain ways by using features provided by Kubernetes itself, topology constraints, node affinity, pod affinity, anti-affinities, and stuff like that. So next up, we have Chaitanya, and he'll be talking to you about all of these ways of influencing scheduling decisions. And after that, we have a very interesting talk on K8s GPT as well. That's a little bit of how you can leverage AI to help you work with Kubernetes, right? Just give us a second and we'll have him set up. Yeah. How should we see this? Is present level, please? Probably. Wait, where is the presentation? Slideshow. Yes, slideshow. Where is your passage? Is it on the other screen? Yeah. Cool. Awesome.
So, hello. Hello. Yeah, hi. So my name is Chaitanya. So I work for Microsoft and I've been working in the industry for quite some time, like 8 years now. So, and recently started working on Kubernetes and came across few interesting principles, and like these are basics and that might they seem like basics, but they help you a lot in scheduling and maintaining your application resilience and availability. So how did I come across this is what I'll be sharing, and how did we use this in our application as well, in our service, which is hosted on Azure, and and the pre and the post implications of this scheduling like principles as well. So I'll be briefly touching upon like what Kubernetes terminology is and the backstory, how I stumbled upon these principles, and what is node labels, node selector, and what does affinity mean, anti-affinity mean, and TSC, the topology, spread constraints, and the limitations of these. And and I'll end with Kubernetes descheduler as well. Right. So since like everybody knows of like what Kubernetes is, but sometimes we end up like mixing and matching the terms. Like instead of like pod, we say node, and we say like referring to a node, we say pod and all, right? So just to clear that out, since I'll be using these labels very often in the next few set of slides, I just wanted to clear out what these labels are, so everyone is on the same page, right? So what does a pod mean? Like a pod is a smallest unit of a Kubernetes cluster, right? So it is where your application or an exe file would run, right? So when you like in pod, like you can have like multiple units that could be running, right? Like one could be a application app itself, and another could be some exe that would be monitoring your app memory requirements or something like that, right? And node is something which is a virtual machine and which is hosting your pods, right? It could be on a bare metal or it could be on cloud, right? And node pool refers to a set of nodes, right? Of which are of the same kind. Let's say in your cluster, you have one node pool which represents all Linux nodes, right? And another node pool which represents a set of Windows nodes. So let's say in this screen, we have like 3 node pools like we have 3 nodes and all of them are represented under one node pool, right? So and cluster constitutes all these node pools, right? So this is at a high level of what node pool, cluster, and node and pod would stand for. Right. Right. So backstory is we were like bringing up a new service in our cluster itself, which was migrated from an Azure app service to an AKS instance. Right. So it was barely new and it was still running. So and I was working on bringing up a new service itself in the existing AKS cluster. So we initially started with one pod, right? So it was still in the testing stage, and we deployed that pod to the production, and it's like nobody is using it, just to see on the memory requirement side, it's everything is faring well, right, on the cluster. So that's we initially started with one pod, and as soon as a week by, another service in the same cluster started calling the APIs which are hosted on the new service, that new pod that I was bringing up, right? So now what happens is we were thinking, like, if I have to bring up or increase or scale my pod instances, like from one pod to two pods or three pods, as the new APIs started coming on the same app service that I was writing, and what like other services also call my app, right? So how would we handle that, right? At the same time, we came across another scenario in our existing cluster itself. So what happened is when we restarted the cluster, let's say there was one service which had like three pods, and all of the three pods got scheduled on the same node, right? And our bad luck, the next day that node went down, right? And it took some time to come back up, like few hours or something like that, on the AKS cluster instance that we had, because of some issue on the Azure Kubernetes service. So because of that, we had a downtime of like 5 to 10 minutes of that app service, of the service which was scheduled on the same node. So like once the node goes down, your workloads will move to the new existing nodes, right? If they have the memory and the requirements to host your the node which went down, and the workloads will move. So we had this downtime for quite some time, and we didn't know like what happened and why the node went down, right? And then I was also bringing up my service as well. So then I started thinking about what should I do as well for my service, so that in future when my service scales, it's I shouldn't be encountering a scenario where all the three pods of my service are getting scheduled on the same node, right? So this is how it started. So we started exploring what are the different pod scheduling principles are, policies are, and how it's done. And so it's not only benefited my new service that I was bringing up, but at the cluster, at a whole cluster level, and all the services which were already existing in the cluster as well. So these are the principles and the affinity pod, node affinity, and the topology spread constraints. It started from here for me, and this is the backstory for it. So I'll be discussing about in brief about them in the next few slides, right? So this is a screenshot of one of the node in our cluster, right? So if you can see, like here, each node, when you open each node on your cluster, you would see a bunch of variables and labels which will be associated with it. Like here you can see like an agent pool, which OS it is running, which zone it is in, like, and which type of instance type it has, and another set of all the possible labels that are supported by the AKS by default will be available here, right? So like I'll be using all these node labels, bunch of them, in the next few set of slides on how to decide to put a particular pod onto a node, right? So each node will have all these labels, and just to clarify one more thing, like in Azure Kubernetes service, so it will be having 3 zones. Like you can like spread your nodes across different zones, and at the same time, when you are scheduling your pods as well, you can make sure that those pods are not only getting spreaded across all the nodes, but make sure that they do get spread across different zones as well. So this gives you both the zone resiliency and the node resiliency as well. So let's say in the data center, if a node goes down, sorry, if a zone goes down for some time, still you will have your service running up, because you have like make sure to spread your pods across not only nodes, but across the zones as well, right? So that is a quick hierarchy of what these labels are. And yeah, so I'll just quickly speak about what a node selector is, right? So node selector is a set of key value pairs that you can put up in your deployment YAML, based on which when a pod is getting scheduled, it will try to obey those node selector values. So let's say in the right hand side, the screenshot, right? If you see the node selector tag, which is at the bottom, I am saying that for my pod, which will be scheduled, I need an OS type of Linux, right? And I need an architecture of AMD 64, right? So this is my requirements for the pod that I want to schedule, right? So if you see in the bottom, I have mentioned like two set of pools, right? One pool is a Windows pool with an AMD 64 architecture, and the other pool is a Linux pool with an AMD 64 architecture. So now when this node has to get scheduled, so it will see from the node selector, right? So it requires Linux and it requires AMD 64. So it will look for that node which has these policies, which has these tags defined, right? So if you see, then only node 4 is what available with the Linux pool and AMD 64, right? So it can go to node 3 as well, and it can go to node 4 as well, based on the scheduling algorithm and the space requirements for your pod. It can land in one of the node 3 or the node 4. And in the further slides, I'll speak about how to make sure that it doesn't go to node 3 and it requires node 4, and how you can control the spread, right? So this is a quick brief overview of what node selectors are. So, right. So apart from node selectors, the other way of scheduling your pods is using affinity and anti-affinity principles as well, right? So node selector, if you might have observed, here we are like mentioning a key value set of pairs, right? So until and unless these key values are not matched, it will not schedule your pod, right? So it means that it's like very strict in terms of effectiveness, like yeah, so it's strict in the sense like until these values are not matched, it won't schedule your node, and it will be in the pending state itself. But let's say you want to control the effectiveness, saying that I don't want to be very strict. I want to be more expressive in the terms of like I want these are required but not strictly required, right? Like you can set preferred rules as well. So this affinity and anti-affinity allows you to do that. Define more expressive logic in terms of how rigid you want to be in terms of scheduling, right? So here, if you see, node selector will only select the nodes with all the specified labels, but affinity and anti-affinity will allow you to like define that hierarchy and like spread and everything, which which we will cover in the next few set of slides. So similarly, for node you have affinity rules, and for the pod as well, you have both affinity and anti-affinity rules as well. So based on your requirements and how you want to lay out your scheduling hierarchy for a particular pod, you can make mix and match of these rules, right? For both the pods and for the node as well. Right. So this is about a quick glance about node affinity as well. So as I spoke, like node selector is very rigid in terms of selecting the labels and stuff. Node affinity allows you to set the space, like if you want to spread your nodes across, pods across different zones and regions. Here in the node affinity, you can mention all those steps, and you can assign weights as well, right? So let's say rule 1, you want to be 100% obliged, and the rule 2, you want only to be a 50% weightage. So how you can set those as well, and based on the weights that you have set for the multiple rules, it will try to combine all those rules for when you want to schedule an pod, right? So as I spoke earlier as well, so here you can set whether you want it to be a required, like an 100% required and has to be obliged, or you can set it as a preferred rule. So as well. So this applies for both pod affinity as well and pod anti-affinity. It has a similar set of rules. So let's see in this example, I am saying that in the preferred scheduling during, like let's say the tag, right, which is defined under the node affinity, which is preferred during scheduling and ignored during execution, right? So I am assigning a weight of 100, and I am saying a matching expression of instance type. So I want a node which is in the which has a tags of standard DS-v2.3 or standard D4 of these versions, right? Instance. So when my pod is supposed to be scheduled, it will look for these two instance types in the node labels, right? So if these are available, it will try to schedule, because we have set it as a preferred rule, not as a required rule, right? So it will try to give preference to these types first. If these are available, it will make sure that these are getting scheduled on that. If it is not available, it will still go ahead and find a node which still has a space and make sure it goes and scheduled on that node, right? So this is about the preferred rule. And one more example of the preferred rule, let's say, let's say in the Kubernetes cluster that you have deployed on the Azure Kubernetes service, right? So we have like zones, like let's say I am taking an example of an AKS cluster which is deployed in an Australia zone. So let's say for this example, we consider Australia has 2 zones, right? Like zone 1 and zone 2. So in the recommendations, let's say in the Azure mentions that zone 1 is more resilient compared to zone 2, and zone 1 has always more capacity. So in your preferred rule set, right, for the pod, you can say like weightage to the zone. In the matching expression, you can say topology Kubernetes / zone, and you can give preference as in weight 100, and then say always try to select Australia 1 for me, right? And then if Australia 1, the nodes which are in Australia 1 already occupied, let's say 80-90% of them space is already consumed, then go and select, let's say 50% weightage that I have given to the Australia 2 zone. So you'll try to always try to schedule on the zone 1, which is Australia zone 1. And let's say if the space is not available, then it will go to and try to schedule on the zone 2, right? So this is how you can set the preference as well of your zones and the nodes for a particular pod scheduling. If you go and compare this with the node selector, right? The first that we saw, we were giving only key value pairs, and we weren't able to say that this is the order in which I want to schedule as well, like Australia 1 or Australia 2. There you can't give multiple values for single key as well. So here you can take multiple values of a same Kubernetes zone and then define an ordering for it. So this is the advantage of node affinity over the node selector way of doing pod scheduling, right? So this example covers node affinity required tag. Right? It works similar to the node selector, but in this, you can specify multiple values, right? So in the node selector, you were doing only key value pair, but here in the values tag, if you see, you can give multiple values, right? Like standard ls 116 v2 instance type and standard ls 32 v2 types as well. So, but the catch over here is we are saying required during scheduling, right? So until and unless all the rule set is not matched, your pod will be in the pending state. Or let's say even if the node goes down and the node comes available and with these matching properties, it will schedule. Until then, it will be in the remaining, in the pending state only. So yeah, so now in this slide, we can quickly see the comparison of node selector and the node affinity, right? So in the node selector on the left-hand side, I'm saying it's like an hash map, right? Key value map on the left side, you can see the node selector tag. I can only mention one value. I can't mention 2 values as let's say I'm preferring East 1 and East 2, both Australia East 1 and Australia East 2. That I can't mention because node selector works as a hash map where I can give only a key value, and value will also be a single value. You can't give a list of things here, right? So, but on the right hand side, if you see on the node affinity topology Kubernetes IO / zone key, I can mention multiple values, right? So if your cluster is where you don't have multiple zones or something, and you require a very basic scheduling algorithm, then you can go with node selector and bunch of key value pairs. But if you want to customize and then give set preferred rules and required rule set as well, and then assign weights to them while scheduling, do consider the node affinity part and anti-affinity rules that you can set in, right? Yeah, so pod affinity and anti-affinity is similar to that node affinity as well. Since we are running short on time, I'll just skip this. But it's very similar to node affinity, and in the same way, you can assign preferred rule set and the required rule set for the pod labels. So instead of depending on the node labels, here you would depend upon the pod labels and the pod that is already running on the node. So let's say you have a service, app service, and you want your app service, let's say, and you have a cache service as well. And let's say you want both of them to be on the same node, right? Since cache should be available to reduce the network hops or something, you want your cache service also to be on the same node. So then while scheduling your cache pod, you can say that wherever my app service node is running, app service pod is running, do put my cache pod as well in the same node, right? So, or let's say you don't want your database node to be running on the same app service node, then you can go for an anti-affinity rule and set let's say if a node is storage pod is running on the same node, don't schedule my app service pod on the same node. So this mix and match you can do, and it's quite interesting to figure out how this works, right? So I'll just skip these screens because they are very similar to the node affinity as well. So the other thing, so till now, whatever we saw is like we were defining policies in the pod deployment schema on how to schedule my pod, right? So then we would say like these are my conditions, these are the nodes that I want, these are the nodes with the specifications that I want for the pod to be scheduled. But let's see a scenario where you have hundreds of nodes or thousands of nodes running your AKS cluster, and you have like multiple pods of the same service that has to be scheduled across different nodes. But how do you make sure of this, right? So you want a uniform spread of all your pods be spread across number of nodes that you have. So this is where topology spread constraints come into the picture. So here topology means you can select different types, right? One topology could be the node and one topology could be the zone, but there could be other topologies as well. So what do you mean by topology is these terms, right? Like the topology over which you want to spread your nodes, you want to spread your pods. Right. So here as well, for the topology spread constraint, Kubernetes allows you to set hard constraints and the soft constraints as well. Right. So I'll just quickly go over a few of these terms which requires TSC to be defined, right? Like topology key is you select a topology key on like to spread your pods, right? Like it could be either a node or it could be a zone, or you could do a mix of both of these, both node and zone as well. And the other thing is when unsatisfiable. This key defines what if the rules that you have defined for the topology key and the max queue are not satisfied, what you want to do, whether you want to schedule anyway or you don't want to schedule. So that you can choose from this. So max queue is the key where you define a value which takes care of your spread. So let's say if you define max queue as 1, and it makes sure that when you select 2 nodes, and let's say there is one pod which you are scheduling on 2 nodes, right? So let's say 5 pods are there and you have 2 nodes. So max queue 1 means that it should be spread in such a way that the difference when you calculate of the same pod on the 2 nodes, it shouldn't cross 1. So let's say for a number 5, number of pods are 5 and you have 2 nodes, right? So let's say 2 and 3 is the spread. Like 2 pods are on one node and 3 nodes are on the other. 3 pods are on the other node. So 3 minus 2 is 1. So that is what the max queue is, right? But let's say if it gets scheduled as 4 pods on one node and 1 pod on the other node. So here if you see the max queue is 4 minus 1, 3, which is unsatisfiable, right? So this always makes sure that the spread is uniform. So with the max queue variable, you can control the spread of your pods and the difference in this number. So so with this example, we can like understand what topology spread does. So let's say I have defined 2 topologies. One is for the node, which is the host name, and the max queue is the other max queue I have defined is for the zone. So I want a uniform distribution of my pods, not only across the nodes, but also across the zones. So if you see in the right hand side, right? So before deployment, this is how it looks. Now I want to schedule a my pod onto the this cluster, right? So now I have defined the max queue as 1 for both the node as well, and the max queue as 1 as for the zone as well. So now let's say in the below screenshot, if you see, my pod is going to zone B. Why? The reason is there are already 2 pods which are running on the zone A, and there is only 1 pod which is running on zone B, which is 2 minus 1, right? The max queue is already 1. So if my pod gets scheduled onto the zone A, then that if you see the queue will increase like 3 minus 1, which becomes 2, but the max queue that I have set is 1, right? So to control that, it's making sure that my pod is not going into the zone A, but coming to zone B. And once it comes to the zone B as well, it's not putting it on the node 3. Because if it puts it on the node 3, if you pick any other node and do a difference with the node 3, it will become 2 minus 1. 2 minus 1 with the nodes which are present in zone A. But if you pick node 3 and node 4, the 2 minus 0, right? So max queue is increased. Max queue is becoming 2 here. So that's the reason it's making sure inside the zone B as well, it's not putting the node on the node 3. It is putting the pod onto the node 4. So you can define multiple max queue and topology spread constraints to control your pod distribution, and this works well and increases your service resilience and availability as well. So this does for our service as well. So since I have very less time, so I couldn't do a demo. So I quickly recorded a screenshot of how it worked on my service. Right. So if you see, this was the initial one of the distribution that happened in my service when we haven't used topology spread constraints, right? So if you see the app one, there are 3 pods for app one, and they landed onto the same node, right? Like, so there is a AKS worker pool 001 and AKS worker pool 001. So if you see, the same node was utilized for 2 pods, right? And if you see, the app 2 as well has 2 pods running on the same node. So to avoid these conditions, what we did, we employed this topology spread constraint. So now if you see, after deploying, this is the screenshot that I took after deploying the pods with the TSC enabled, right? So if you see, if you pick any app, and let's say if you pick app 2 as well, so they are even like uniformly distributed across node 0, node 1, and node 2. So this topology spread constraints make sure that whatever nodes that you have and all the apps and pods that you have are uniformly distributed across all the nodes. And you can consider the zone topology also. If you see, no pod is like scheduled in the same zone twice or thrice, right? So this is how you can control scheduling of your pods and make sure the availability and resiliency of your services overall at a cluster level is high, right? So, right. So this is limitations. Right. So if the one point I would like to touch upon is, let's say if your AKS cluster which is deployed doesn't have a auto scaling enabled, right? And if your node goes down and all of your pods have moved down to the other nodes, and when your node comes back up, Kubernetes will not disturb the already existing pods that are running and healthy, right? So even though the node comes back, it will still be an unutilized stage if you haven't deployed a auto scaling AKS. So in that case, you can make use of a descheduler with different set of principles set in. So this descheduler will can run as a job or a cron job or a deployment itself in your K8s cluster. And based on the limitations and the principles that you have set in, let's say if you have set in the pod constraints and the topology spread constraints, descheduler will make sure that those are obeyed by descheduling the pods and making sure that they are moving to a other node which is empty. So I will share this deck anyways. So these are the references that I had. Yeah, so that's about this basics of node selector and topology spread constraints. Yeah, if anyone has any questions, I would like to take those.
Cool. Thank you so much, Chaitanya. You can see what's going. So next up we have Suman. That's the last talk for today, and he's going to be talking about K8s GPT and how you can use it as a sidekick to Kubernetes debugging, right? So is it presented? Just give us a second to get it started.
Yeah.
All good?
Hello. Hey, hi everyone. I don't want to keep you in sleep because I know there has been some fantastic talks and it's almost like the end of the day. Yeah, so I'll try to keep my talk as interactive as possible and as well trying to make it more useful in general for everyone as much as possible. Let's see. So just give me a second. Yeah, so a bit about myself. I'm working at VMware, which is now part of Broadcom. I have been a active community member and I have been speaking in many conferences around, especially around DevOps tools, Kubernetes, cloud native technologies. And when I'm not speaking around, I would be having good food and I'll have to travel. Yeah. Okay, so before coming to the current state, a quick show of hands, like how many of you are serious DevOps and SRE engineers, are working day in and day out? Maybe I myself. And the next question, how many of you have been paged in the middle of the night for some serious P1 incidents?
I have been in the past. Okay, so welcome to the talk. So yeah, so let's understand the current state actually. So what we have, so we have certain ML solutions which have been already there in the market, which is taking care of your application performance, observability, taking all the root causes, issues in the clusters, and anomalies, and they are actually sending in form of some alerts, events, or you can integrate through certain communication messaging platform, right? Now, what happens or what has been seen mostly is this solutions more act in silos, and they don't give rich context about the events that a DevOps or an SRE engineers would like to have in order to debug that. That's why most of the time we fall back on Stack Overflow or sometimes now relying on ChatGPT, right? Yeah, so basically this is the problem actually. So the SRE DevOps teams need to understand the issues closely. They need to understand how those different events are coming and then triage that issue. One more thing that has been seen in most of these ML platforms that has been created, there are no defined run books. That means they are definitely throwing the problems, but then they don't give how that particular problem has to be approached, right? And another major thing which is quite critical in today's IT infrastructure side is about security and vulnerability. So ideally, as an SRE or DevOps engineer, I also want that if there are certain issues coming, right, it should also highlight me if there are certain severe vulnerabilities that is there or not, apart from the regular events. So let's introduce K8s GPT. So K8s GPT is one of the tool which can act as a sidekick for you in terms of this kind of issues that when you are debugging inside your cluster. So how does that do? So before that, we'll explore a little bit about that K8s GPT. K8s GPT is an AI-powered tool which is created to help manage manage Kubernetes clusters, which are conformant Kubernetes clusters actually, and it helps you to scan the cluster, diagnose the issue, and troubleshoot that issues as well using the natural language processing techniques actually. So this tool was basically bootstrapped last year in KubeCon at Amsterdam 2023, and it's now open source license. So this tool has grown, I would say, by leaps and bounds, because with 1 year itself, it is now already adopted in CNCF as a sandbox project. And if you see about the stars is like 5,600, it's a very good, if you say from any open source project point of view, and almost it has 50 plus contributors. So what actually K8s GPT is offering to us? So K8s GPT as a tool, as I told you, that it basically scans your clusters for any issues. It basically helps to diagnose this issue and basically help to create different root cause analysis of the events, which is enriched by AI. So what is there is actually within K8s GPT, we something called as an analyzers. And these analyzers provide SRE-based context, which is again being adopted or being filtered out using the AI backend tools and providing a rich context of how that particular issue needs to be approached. And since this is powered through an AI provider, so it can be, it actually contains the solutions in a very standard English way. So anyone can go through and you can read through and understand what it is trying to make out. And apart from any other tools, one important factor with K8s GPT is that it can also helps to triage issues that contain serious CV vulnerabilities. So it basically provides you all the images that might have certain issues at the libraries and try to help you find out how you can basically mitigate that. And the last but not the least is a thing which I'll discuss later, but it is something called as bring your own analyzers. That means apart from the standard analyzers, which is provided by K8s GPT, you can actually develop and create your own analyzers based upon your environment, based upon your custom needs, and you can allow K8s GPT to manage that for you. So let's see. in action how it works, actually, the architecture side. So K8s GPT basically contains a set of analyzers. As I was telling, the analyzers is basically the brain of this tool, which contains a series of rules and checks which an experienced site reliability engineer will use to diagnose their Kubernetes issues. That might be pod crashes, that can be ingress misconfiguration, service failures, anything. And what this analyzer starts scanning the cluster across all the namespace for different logs, events, messages that are coming into your cluster, and then helps to identify these potential issues. And then what it does, apart from not only it's collecting these issues, it is also correlating these issues with some additional checks, which is built within the K8s GPT, and to give it a more rich context, and then sending it to an AI backend. So in this case, at this moment, K8s GPT is supporting almost all the popular AI backends, whether it's basically if you're using, let's say, OpenAI, or which is basically the default provider for K8s GPT, or Olama model, if you're using Microsoft, OpenAI, Amazon Bedrock, local AI, anything, it is supported. And then once it sends to the backend AI, it basically gets a response back on the particular corrective action and the solution that has to be taken. And then it is sent back to the user for their action. So this is a very simple way how it works. And as I was mentioning, that analyzers are the brain of this particular tool, and it is this analyzers which tells tells what action needs to be done. Like, let's say, for example, you see that in this particular analyzer, it says that if your PVC is in pending state, then what action you need to do. If there's a provision failed, then what error you need to append to that particular context and send it. So these analyzers are built-in analyzers, which are enabled by default, like pod analyzers, PVC analyzers, replica set analyzers, event analyzers, ingress analyzers. There are a bunch of analyzers. While certain are optional, which you can enable based on your requirements, such as PDB analyzers, network policy analyzers, log analyzers, HP analyzers, everything. So using K8s GPT is very simple. You can install it as a CLI across, and it is supported almost all different operating systems. And also it is supported as an in-cluster operator. That means you can actually deploy it as an operator within Kubernetes. I'll talk about that operator in next few slides. But just to give away the context that how this K8s GPT CLI can be used, we'll just quickly go through a short demo maybe. Let me just switch. Okay. So once you have installed the tool, then what you need to do, you need to basically integrate this K8s GPT with your backend AI. So the simplest way is basically doing a K8s GPT generate. And what it does is basically once you run K8s GPT generate, it will ask you to authenticate with OpenAI model. So OpenAI is basically the default provider for K8s GPT. But you can choose to use your own AI backend as well. In my case, I'm not using OpenAI because I don't have any free tokens to use for my services. So what I had done, actually, I had used the Olama. So I have deployed it in my own machine, and I'm running this locally. So this is actually using Llama 3 model for computation, and I'll be using K8s GPT to integrate with Olama. So I mean, this has been integrated, but the backend that is used here is the Olama, which is running locally. So if you just start with K8s GPT auth list, providers that it is currently supported. So as I told you, right, so almost all the popular AI models are currently supported, whether you are using Gemini or whether using OpenAI or whether using Azure OpenAI, Bedrock, Hugging Face, Google Vertex AI, most of them currently are supported. And so you just bring your own AI backend and just integrate with that. Another important thing, as I was mentioning, is about the analyzers. So to use the analyzers, you need to understand what are those which are currently available. So if you just do a filters list, it would basically show you that on what particular resources this analyzers will work. If you're using stateful sets, node, replica set, cron job, deployment, persistent volume claim, ingress service, for all them, the analyzers are automatically enabled. While there are certain unused means these are already there within the tool, but you just need to enable them. So these are not enabled by default. And so you have a wide range of configurations that you can actually use along with your with this particular Kubernetes GPT tool. So let's start analyzing our cluster first. Okay. So to start analyzing, what I'll do, I'll just run Kubernetes GPT analyze, and what I'm trying to do. So I have purposefully created certain misconfigured pod, which is basically not in a good shape, and I would try to see and like I would try to know that what basically Kubernetes GPT gives me about that. So to understand any issues, you just need to provide the particular namespace where you want to get the resources, and then you need to sorry. Oh, zoom in. Is it fine?
So can you just?
Yeah, sure. So yeah, so let's see. Here in this case, I want to basically understand what is the issue with my current namespace broken deploy. Now, this is not that you have to always give that particular namespace where you are concerned to. You can actually give or you want to check whether in my cluster things are fine or not, right? So in this case, you just need to mention Kubernetes GPT analyze, explain, and output format you can give in JSON, you can give in YAML. It supports different output formats. And probably for, I would just give a JQ dot just to give it more in a representative manner. Now, what it will do, it will scan my cluster. It will tell me what is the issue with my cluster. So let's see how it does. So in the backend, it is sending the request to my Olama server. As you can see that it is basically being, the Olama has the Llama 3 model involved, and it basically has a built-in runner which gets started in 8.4 seconds, and there would be certain requests that you would be getting. So in the initial run, it basically takes some time to get the data. So we'll just wait for 1 or 2 minutes. And since it is actually scanning the whole cluster, so that's the reason that it is getting more and more response as close to the actual output that it should be. So as you can see, there's an API generated request that has already got from my Kubernetes GPT side to the AI backend. So it will just show me here for some time. So at any point of time, the first run will always take a little bit time because here it tries to cache the result as well. Because this I'm running for the first time, it will try to get the results and then it will cache locally. Now, in this case, there's one more thing where you can actually cache the result into an external provider, like whether you are using S3 or using any other cloud provider, you can actually set your result to store in that backend provider so that whenever it tries to get the result, it will query first from the cache provider, and then it will try to get it. If it is not finding, then it will try to get from the server itself. So you can see all these requests is going that I have sent here. So we'll wait for a few minutes more. Actually, I should have done it on a namespace level because it takes a bit time to collect the results from from all the namespaces. But anyways, let's see. So we'll have some data here. Sorry? Yeah.
Sometimes for complex problems
Correct.
like you're debugging HTTP or something,
Yeah.
no? It'll give you some bunch of false things you'll try for 2 days and be like, why did I waste my time on that sort of?
No, so basically in this case, what's happening around is like ideally we should not get that false result much because within that K8s GPT code, it is redirected to get the query as close as possible from the Kubernetes side documentation mainly.
Okay, so your experience, it's been flawless. No.
Yeah, I mean, I'm relying on this to give me the results. So
I see.
ideally, I'm expecting that it should give the result as close to as possible. So there's an option where we can actually, in this I haven't passed, where you can pass an -d, where actually it will tell you from which particular doc it has referred that information and is sending you actually. So this is a bit, again, see, it's an AI, right? So it will obviously can have some flaws, but it's always better to validate that against the actual runtime environment before taking any action, actually.
Thank you.
Yeah.
Hello, yeah. So you mentioned like it is licensed with Apache.
Yeah.
So like, do we have to pay or is it currently free of cost at the moment?
For the, I mean,
Just GPT, you said it is licensed with Apache.
so for that OpenAI, currently you when you registered as a normal user, you get around about, I think, few tokens which are available. But again, when you are running any actions on that particular cluster, it will consume more than that token. So it's almost like it's not free. Previously, when it initially started, OpenAI was giving the quantity of free token was more, where you could have done this set of actions, but now it is not much possible actually. You have to be a paid user, and you have, because every request that goes to the backend API generates tons of tokens, which basically gives the result more closely as possible actually. And unless and until you are going as a paid user, you will not be allowed to get the token back actually. So that's why. So that's why, I mean, if you ask me what is the best way, I would always try to have my AI running locally. I mean, locally means where I can develop my own model. I can basically provide it with more actual context that it is needed, rather than going into any cloud and fetching the results back in. Because one thing is like, even the data I'll be talking about, even the data that I'm sending right to the AI can be compromised at certain aspect. Though there is a way in K8s GPT we can do certain kind of masking, but again, since it is going to the cloud, I'll not basically I'll not be comfortable like any other customer who are using would try to like to retain the data locally in their server. So any other like in most of the situations when we are working with this kind of environment, we try to build the AI locally instead of going and connecting to a backend cloud service actually.
This like Llama server that you mentioned.
Yeah.
Like first thing first, like we had to set up this server first.
Yes, so you need to basically run Olama first. So Olama right now can be installed directly. So it's an open source project. There's no license involved. And this is using Llama 3 model, but you do have an option to use Llama 2 as well. Again, just like Olama, you have something called as a local AI, which also you can set up that actually uses Olama in the backend. There's something called as a no API as well, which mimics that of an AI backend model, but it doesn't give the result as close to as possible because it doesn't use any token. It's just for demo purpose. That's it. Nothing more than that.
Understood. Thank you.
Huh? It is basically yeah, like K8s GPT is inbuilt in a way that it sends the correct context to the AI model, which it needs to point out. And inside the code, it is basically referring that which particular document you should give refer and get the result out that you can send it back actually. Documents doesn't have the errors. So what it does, it basically analyzes the result based on your clusters values that you are sending to AI model. But the solutions or the remediation that it is passing, it is giving from the documentation. Okay. So it is not doing any auto remediation. So obviously at this moment, though there is a roadmap to do auto remediation, but yeah, so it has come. So actually it passed through all the cluster related issues, and so it took some time initially. So as you can see, like when it is passing, it is actually telling me that which particular resource has a problem and what actually I should do. So basically there is certain resources where endpoints are not ready, and what is the details about that. So if I'm coming as a novice Kubernetes user, I don't know anything about endpoints, right? So this should give me some highlight, some understanding that where these endpoints should be there, what the endpoint should contain actually. So all these things. So it will be basically giving you all this in detail, telling you that there, if you are not using the correct image, what should be the steps that you should take. Now the next thing is like one more interesting feature I like about this is basically the interactive. So this is more about a request that I've sent to the AI model, and it has giving me the response. But if I just give like one moment, say I'm just giving now a single namespace. And there's a flag called interactive. And I want to understand without going into the details, like let's say where basically I don't know nothing about troubleshooting. How should I go and what should I check? Okay, so I suddenly something came up in the middle of the night. I'm having a problem. I don't know that what is this back off pulling image means actually. I don't know anything about Docker. I don't know anything about Kubernetes. So I'll simply ask that where should I check if the image passed in the manifest is correct? As a very layman term, like I've just passed. Oh, sorry, I think I've just mentioned what should. Let's see. Anyways, if it ignores my typo. So what it would do, basically, once you pass that interactive flag, it would be something kind of like a sitting as your coworker beside you, giving you guidance like how you should go and try to debug this particular issue, right? So anyways, it has given one like 4 different like the solutions in steps, like check the pod logs, whether the logs gives you any specific error or not, verify the pod status. Their pod status should be showing either, let's say, in a pending state, or it is some container config error state, something like that. Check if the pod is still running or not. If not, try to restart the pod. But again, if I don't know anything about the Kubernetes way of working, what I should do, then where should I go? So this is what it's saying, that you should check if the image tag is correct and exists by running the following command: docker pull nginx. So this is a good hint actually. If my image is correct or not, I can just simply do a docker pull in my system and can see if my image is coming from, I mean, if I'm able to pull from the Docker registry correctly or not. And this is the way how you can go ahead and start interacting with this particular tool. You can just ask him any questions and it will try to give you the answers as closest as possible. So this interactive mode was recently being enabled, I think 3 months back on this K8s GPT, and it was being asked by many users, many contributors to give this, because many people who have started using K8s GPT in their environment, they were not able to get the data, or they were not able to understand what that AI backend is sending them, right? So that is the way how they started working. So I'll just exit out from here. One more important thing, I'll just quickly show you that sometimes in our naked eye, we would not be understanding if there's certain issue in my resource or not. For example, take this pod, which is running in this broken deploy. Do you see any issues? There's no issues. It shows running. Okay. So let's see if KTSGPT is able to find any issues or not. So I'll just remove the interactive. Probably I give broken deploy, minus output, JSON, maybe a JQ. Let's see. For us, it's simple, like there's no problem. The pod is running fine. What KTSGPT says. Oh, so KTSGPT has detected some error actually. So service has no endpoints. Expected label app is Nginx app. So if I would now go and see my pod manifest. Yeah, correct. So it has picked up correctly. So everywhere, whenever I'm passing the app as a label selector is given as app sample hyphen app. But here I'm passing app Nginx hyphen app. So this means there was no issue, but when ultimately I was able to access that app URL, I will not be able to access. And then my debugging starts. But here in this case, KTSGPT immediately realized, hey, there's some issue. First fix that before accessing the app. So this is what it has detected, which we could not detect as a human being, which is scary actually. I mean, it should not happen that AIGPT replaces us, but anyways, nevertheless. So let's go to the PPT. So as I was mentioning that KTSGPT can also be installed as an in-cluster operator. So what this allows actually, so let's say I want KTSGPT to run 24/7, right? So basically I can install that as a Kubernetes resource, and it will basically get the metrics, push it to the Prometheus script, and from there you can throw it on the Grafana to see all the events or alerts that is coming. So this is more with respect to any CI/CD pipeline that you are trying to create and trying to adopt KTSGPT within your existing pipeline, where it can give you results every time whenever there's new events that is coming in. So the next thing that can come to us that, okay, it's fine, KTSGPT is helping us to price the issues by getting the logs and data from the cluster and sending us what should be the next step of action that we would take. But is it safe that we are actually sending our clustered data back to an AI backend provider? Yes, so this is not safe. So for that purpose, KTSGPT implements something called as an anonymizer. So what it basically does is that if you pass this flag --anonymize, it will basically mask all your Kubernetes resources. So whether you are using the pod name, whether using the deployment name, or even the service name, it will mask the data before collecting the data and sending it to the AI backend. Once that AI backend has analyzed and sent the data, it basically does a de-anonymize. That means changes it back to the actual Kubernetes resources, and then it is returned to the user. In this way, you are basically honoring the confidentiality of your infrastructure resources without compromising the any secrets or credentials that can be passed by mistake whenever you are running this actual tool. So in conclusion, KTSGPT is still a nascent project. It's just a year old, but the way how things have shaped up, it's actually something worth to praise, because almost like 50+ contributors are contributing for actually helping it to grow and triage most of the issues that are being faced within the Kubernetes ecosystem, because as Kubernetes is also growing up with respect to different technologies coming in. So we do see different newer issues that are coming day in, day out, right? So that's the thing that KTSGPT is trying to focus more here. And we do expect new features to come in the horizon, especially right now. Auto remediation is not there in place within the KTSGPT. That means it can identify, it can tell you that this is the issue, this is the solution you should look forward. But then it doesn't do any auto remediation. It still relies on the manual intervention. So this is something the community contributor is pulling their socks to get more into the idea of how this can be done. Carpenter integration is still not there, which can actually help you to basically do some kind of an auto scaling enablement within the KTSGPT. And also there are newer backend APIs that are coming in. And so we would expect more such features to be integrated. One important feature that is still missing is that at this moment of time, K8s GPT doesn't mask any events that it is sending to the backend API. The reason being that it doesn't know that in even which particular data it needs to mask, because we are not sending a simple one resource, two resource, we are sending a tons of resource. So ideally, there is a specific issue which has been raised on the community to understand that which specific area we should highlight, because this is very important in order to send the data and in order to safeguard the interest of the resources which are used within any infrastructure environment. So these are some of the repo. You can maybe take a screenshot that you can refer to that. If you want to contribute, definitely everyone is welcome here. And like we can always chime in with an idea. If you have seen any, maybe a very different issue within your environment, then definitely you can put it as a request how K8s GPT can improvise that. Yeah, so that's all. So any questions?
Hi.
Yeah.
So my question is, how do we manage this context given to the, like what you demoed, right? So when you don't mention any resource, it goes through the entire cluster and all the events and maybe the logs.
Yep.
The context is really huge.
Correct.
And how does it handle that when the model is restricting the context length or the token inside the context?
No,
How does it handle
so as I showed you, right? So here you can mention the context as a namespace. Like here in this case, I'm using namespace to restrict my scan on a particular within a particular area where I know that there's a problem. In this way, you have something called as a filters, which you can actually use to filter specific resources only. Let's say within your cluster, you want to filter only the pods. If there's any problem within pods, or if services, or if deployments, then you can just pass a filter flag with that particular resource name. Then it will just give you that particular information related to that particular resource. You don't have to go and always scan the resources. I mean, all the entire resources actually. So that is
the question is particularly on when we don't use the filter, how the backend is handling this, generating the context.
I mean, you mean the how the AI backend is generating this context?
No, before we send it, the entire context to the AI.
Yeah.
Along with the
Okay,
prompt.
okay,
how
understood.
it-
So what it does is basically K8s GPT looks for all the logs, messages from every resources, all the events that, like we have this kubectl events, right? So if I just run, so maybe there's nothing in the default namespace. So these are all requests, right? And that is there, right? So it basically takes this as one of the input and then basically improvises that with some of the codified knowledge, which is already put there by the contributors. I mean, you saw right that there was an analyzer, right? So where I showed you like what action needs to be taken if, let's say, the PVC is in a provision fail state, whether they should add any event messages or not. So all this state, it basically correlates, creates a new context out of that, and then sends it to the backend API actually.
So it's like we know the patterns and we pre-process this entire context.
Right.
And then send
Correct.
Okay.
That's why the requirement is like if you are running let's say a custom Kubernetes environment, right, where you might have certain a bunch of custom resources deployed, which is having its own life cycle, right? So you can build or create a new analyzer and then add it into K8s GPT to monitor on that particular resource as well, actually.
Thanks.
Yeah.
So I just wanted to ask, what are the integration points available in terms of, let's say, we want to do some alerting based on this?
Right, good question. So actually, I thought to show that. So right now, with K8s GPT, you can actually integrate some of the services. So let's say you want to scan your cluster, right? With Trivi, then basically you have the Trivi that you can add and run that same when K8s GPT is going through and running all those checks, right? So it will also give you a report of all the misconfigured pods or that is using a vulnerable image and all those sorts. Let's say you are using like you must be using something to monitor your admission policies, right? So you can use Kyverno as one of the solutions that will act as a gatekeeper and gives you all the policy report of all the checks where some resources have been violated. So this list, this list has coming up, and these are some of the resources which are currently available that you can create. But before using that, you need to basically enable that particular service. Let's say I need to have Trivi running in my cluster, which K8s GPT can interact to fetch the report and send you actually by analyzing with the AI backend actually. So these are all the integrations right now that is possible.
Does it only show the current snapshot, or does it have a historical information? Do we need to integrate with some caching or something for it to show some historical issues?
Yeah, definitely. So as I mentioned initially, right? So you can definitely cache the result. Okay. So here also, if I would show you. So you have seen like in some of the query has come up very fast instead of the first query, which was taking quite a long time, because these results were already cached locally in my node. Okay. So you can definitely take this cache and add it to a remote backend as well. Like you might be using Amazon S3 in this case, right? So you can basically update that in your create a bucket and update the results so that whenever it calls, it will basically cause the bucket to get the data and show you. But the thing is, like, whenever you are caching only means that you don't spend much time to go through the same set of issues over and over again. But I strongly believe that in Kubernetes, you should ideally get the runtime data, because you would be getting issues differently. Like maybe there's maybe your pod is not your pod is not running. That doesn't mean that every time there's a wrong image that is because of that it is not running, right? So there can be certain configuration issue. Might be you don't have enough resource capacity because of which the pod is not able to schedule. So cache is one of the way where you can get the results quickly. But again, relying on the runtime results would be actually the go-to forward for using this kind of tools to get more accurate results actually.